Hi, welcome to the next practical session of embedded software testing. Today we will see the exercises regarding test cases uh, and scenarios from a set of requirements which we had studied about the requirements in the last class, and try to study that with requirements and the corresponding test cases. So we had also gone through the example SRS. It's called embedded unit instrument. So we'll just try to recap that. Then we have a test review checklist. So this is based on high level testing. So there is a sample here. This typically being done as a uh, completion step in order to take the credit of the embedded software testing high level testing that is being done on the set of requirements. So this checklist will talk about the rules and whether those rules are followed, and whether that embedded software testing can be taken for the next level. Like this it will be used. So that is how the rules are being used. So once these two exercises are done, we will try to continue the exercise in terms of identify and establish a traceability matrix for the developed test scenarios from the set of embedded unit instrument requirements. So you know the traceability basically is required to see and report that from the requirements to test cases how the coverage is there, how we are able to trace different requirements to test cases. Similarly, test cases to requirements. So two are different basically. I mean, though we call it as a traceability, so both are required because the coverage perspective is different. So test cases to requirements is called as a upward traceability, and requirements to test cases are called as downward traceability. Okay. Now let's try to recap the requirements. So SRS1 talks about the embedded unit instrument operating in 5 operational modes such as unit, operational, maintenance, download and fail. Here you can see different modes of operations, how they can enter and exit. So there is a parallel mode of operation is fail, which can go from any of these unit, operational, maintenance, or at any point of time based on the different conditions. So those conditions are nothing but the modes of operations. So typically SRS2 onwards we have different modes of operation requirements. I think we had gone through this. SRS2 regarding modes of operation, SRS3 as well with the init mode, SRS4 about operational mode, 5 is about the maintenance mode, and 6 again maintenance mode. So likewise we have different modes of operation, SRS2 to SRS5, 6 are there. Similarly, we have performance requirements in terms of SRS7 to 11. Here we know that the booting time requirements and the workload, the performance of the processor or the CPU, how much it should be, and also along with the timing and the workload, we have the memory related performance requirements such as flash memory, RAM memory, stack memory. So how are we going to verify those? Let's try to go with some few example test cases, so that that is a framework on which the entire testing can be taken up further in terms of test scenarios as well as execution. Similarly, we have a communication requirements in terms of how the instrument unit can communicate with the external world. It is through CAN messages. We know that because the first requirement talks about the different messages it is receiving, and based on different messages it is going to different modes of operation. So there is a watchdog requirements. You know that watchdog should be pulsed less than 500 milliseconds. If it doesn't pulse, it is going to reset. So these are some of the requirements for which test cases have been developed. So let's try to understand the test cases. In one of the session we studied about how a test spec or the test cases should be existing. So we need to have the requirement document, test plan. We assume that test plan is available, and test spec, which is nothing but the test cases, scenarios corresponding to the requirements. Then we are going to group it. Then we are going to trace it. These are some of the specific activities that we do for developing the test cases, and in the test specification we are going to have a strategy in terms of how we can do it, then practical steps which are nothing but the test procedure. This is how we do. So these are some of the things that we need to do. So we know we have gone through an example of template how it should look like in one of the theoretical class. So let's say to understand the test case perspective, how it can be developed. Okay. So we have about 1, 2, 3 levels of 4 levels of requirements in terms of modes of operation, performance requirements, communication requirements, and watchdog requirements. Okay. Okay. So we know the templates how we are going to use it. The first section should talk about the test case identification for each of the requirements. You can see as far as each requirements we need to first identify test case. I guess we have gone through this template how it should look like. Like you should identify with the test ID. It should be unique for each test case, and what is the input for that particular test case. So what is the condition that for this input it should exhibit, then what is the expected result that we are going to have. Similarly for each of the requirement, like we are going to take up SRS2, SRS3, SRS4, likewise we are going to have for each of the requirement. So that's how we are going to develop test cases, and the grouping is based on different functionalities. Like first few cases we will concentrate on the modes of operation. The next one we concentrate on performance requirements, and next grouping is based on the timing, and next group could be based on the watchdog. Likewise we can group it, but before grouping, first of all we need to have is the test cases individually identified for each of the requirements. It's very important, and basically we can adjust like what test case can go into what, and can we club it, or is it duplicate or redundant in any aspects that we can do. So first and foremost thing is develop the test cases for each of the requirements. Once we are done with all that, then we are going to have a grouping. Once the grouping is done, and we know that for each group there is a set of conditions that need to be existing before we start the practical step or the test procedures. So what are those conditions? They are called as preconditions. So precondition, for example, I have put for one of the test case, we can have test group 1, so which is nothing but relating modes of operation. So what are the things that we need? We need to power on the unit and set the below values. Below values could be something like what are the inputs for the unit should be hooked. So what are those? One could be CAN message adapter should be up. Similarly, any interconnected interfaced memory subunits should be powered. Okay. So what else we need? Some discrete we could need should be up. Likewise, we are going to have the preconditions. So the precondition can be unique or different based on the type of group that we are using. So for modes of operation, we need can messages should be coming, because without that we cannot test the modes of operation requirements. Similarly, uh, like we need to apply power, a voltage of 5.0. So likewise we are going to have it, and some of the requirements we may not be able to do dynamically, correct, no? Or when the target is running. So those list for static analysis, where we need to do it static execution is by seeing the code. So like performance requirements, some of like memory map, those things you don't need to execute on the target. So those cases we are going to list it out here, telling that that group of or that specific scenarios can be tested statically or static analysis based on that. Similarly, the template talks about test scenarios categorized under functional or operational requirements. Next, test cases scenarios categorized under non-functional requirements, etc. That means basically whatever the user or business based functionality means the instrument should be doing some functions like it should rotate the motor. That is an actual requirement. Some of the non-functional requirements such as it should power up within 5 seconds. Something of those test cases, they are not business related or user related. That is all performance or supporting sort of a requirement. So likewise, we are going to have the appendices updated for the test case document. That's one section that we have. And the first sections what we have seen is test cases identification per each requirement. So this is what we are going to do. So for example, we'll study few requirements and few test cases per se. Okay. So SRS2, we know that what it talks about. It talks about the modes of operation. Like we know that the instrument shall set the mode to failure mode in the following cases. There is a OR logic. So one of these conditions, one of these preconditions, if it occurs, it is going to enter into failure mode. That is what the thing. So here, what is the input? These contents of this having the inputs. So let's try to understand one content or one condition. When mode is in maintenance state, so mode is an input, and received message is an input. So what is the output? Fail mode. That means again mode set to fail mode. Condition is what? This itself is a condition. So first condition, second condition, third condition. So one of these conditions exists, it is going to enter into failure mode. Okay. Let's try to draw an example case. First test case. Let's try to define. So we know that mode is an input, receive message is an input. Why? Because scan message it is having a dependency, right? So message is one input, mode is another input. If these two are inputs, we are going to apply some conditions for that input, and we are going to get the expected result. So what will happen if mode is in maintenance mode? Correct. If this input is satisfied, and when we get a receive message of 01 CRLF, don't worry about what is it CRLF. That is a message, just assume that, because we are focusing our emphasis is to test this portion, not the actual data. That maybe for robustness in terms of a different message other than 01 CRLF, what will happen? That maybe we can define later, but we will start with a normal case saying that we have fed two inputs, maintenance mode and a message with 0 and serial number. Directly as per the requirement, we should go to fail mode. So this we have tested here, and in the next case you can see we are trying to test with a second message 0 to CRLF. In that case also it will go to fail mode. Similarly, the third condition, when the mode is in init mode, if the status is in error state, that is during initialization, if any error occurs, it will go for failure. So these are straightforward test cases that we have seen for this requirement. Similarly, if more conditions are there, we are going to apply as per that. Okay. Next, let's try to define. Now this is OR logic. So that means any of these conditions or multiple of these conditions occurs. So we have something like A or B or C equal to D. D means it's a failure mode. So we are going to have a truth table sort of a thing where either A can be set to true or B can be set to true, C can be set to true. In that condition, this should go to fail. And next one, A, B set to true, A, C set to true, A, B, C set to true. In this condition also it is going to go for failure. So likewise we are going to have, this is called that MCDC or the modified condition decision logic, because based on the condition different decisions are taken. Here when A becomes true, the condition will be fail. When B is true, condition will be fail. C is true, condition will be. Similarly, A and B both are true, condition will be fail. Right? Both are true, fail. Both are true, fail. Similarly, A, B, C, last case, when it's become true, it will be fail. Next we have what else we left? Everything we left, right? Everything we have written. So in these kind of things, it is good to have something like a truth table. We can define that way. It will be easier actually. Maybe I'll try to have one more column added. So A, B, C and the output is what we are trying to set for different values. So we know that combinations of A, B, C, we'll try to set 0, 0, sorry, 1, 0, 0. Output will be fail. Similarly 0, 1, 0, output will be fail. This will become 0, this will become 0, C will become 1. Next condition 0, 1, 1. Typical truth table we are going to have it for all the combinations. Moreover, we may not need, because we know the result of this. Why we may not need is the independency we need to prove. I will try to explain that. Okay, here you can see the multiple truth table combinations, like C is true, output will be false, and B is true, output will be false. Similarly, both are true, will become false. And now we are going to set A as 1, and we are going to vary it here. This is going to be still true. The last condition is 0, 0, 0. It will become true. That means true means there is no failure or not a failure. Here in this case, there is a failure, right? Okay. One more condition is all should be 1, should become failure. F means basically failure. Okay. Okay. So for each of these, we need to develop the test cases, adding the inputs accordingly. Okay. Now we have tested about these normal cases of with the truth table and modified condition logic with this. Next, within each of these, we can identify another test case or another group of test cases, such as, okay, I'll try to draw that only. So input is mode, maintenance mode, and receive message is 01 CR LF, right? That we have already tested. This will become fail. Okay. The next condition within this test case, input mode is not of maintenance mode. That's not, we don't know what mode it is. So it will become no fail, correct? Because we are not all there in that actually. Okay. The next one, input is in maintenance mode, but the received message is not 01 CR. It is something else, XXXX, whatever it is. So this also will become no fail. So like this, the combinations that we need to have, that is very important. Once this is done, then we are done with the complete test cases, and we are going to apply it. Okay. The next thing that we need to take care is the independency. Very important term. You can see in the above case, ABC is set here, it is recorded false. Now we have proven only the B has changed from 0 to 1, whereas the remaining things are constant. That also we need to prove, right? Because remaining thing is not constant. Here we have seen B has changed along with C also has changed. We don't know because of what the failure would have occurred. So better to have a independency such as setting it back to 0, so that we are proving the independency with this. Because of this only the failure has occurred, and not because of this or the combination of this. So that is how independency we are going to prove. Similarly for other cases also, like we have 0 0 0, no fail, and since this has toggled these two bits, because of this we are getting the fail. So that's how the effect of the inputs we need to tackle it appropriately, so that independence is proven. That is one of the important things that they look for when we are going to write the test cases. So that is how we are going to have for different sort of combinations and inputs for that particular requirement. Okay. Next one. Next one is SRS3. This talks about what when the mode is init mode and the status is no error state, that means there is no error when the init is in when the mode is in init mode, the instrument shall set into operational mode. So two inputs, mode and status, init mode, no error, it will become operational mode, mode received message, mode and received message. So this is not a right test case. Maintenance mode. Okay, let's not write to this. We will try to do a simpler one. Mode, status. Okay, non-init mode, Okay, let's put it more simpler. It is in init mode. Status is error. So what it will become? It should not be not of operational mode. That is for sure, because the requirement says it should be there in the operational mode only when there is no error. So by going through the operational mode requirements, it is clear for us probably by seeing if it is not of operational mode, what is the mode it's going to take care. Let's try to go through the requirement again. We'll come to know. Requirement is okay. Yes, it is going to go for the failure mode, because if it is going to be no error state, then it will be operational. Otherwise, it is going to go for failure mode. That's what it says, right? Okay. So nothing but it is nothing but fail mode. So likewise, we are going to add test cases by looking at the requirement. So for 3 we have done. Okay. 4 is regarding maintenance status, status alive messages, and 6 is about the next set of messages 04 CRLF. Likewise, we are going to add it. You can see particular SRS, and for that test cases we are going to add. One more thing you would have noticed is interface requirements tested. So what will happen is some of the signals that are having a dependency for particular requirements, suppose for this functional requirements, there is a signal dependency is there, some discrete, and that we need to list. And by listing that, we are also trying to test that particular interface requirement. So that also we need to cover it as an input. That may not be a full-fledged functional requirements, but there is a dependent interface requirement. Okay. The next one is performance requirements. Let's try to understand what performance requirement talks about. The entire process of booting up till operational mode should not take more than 1 second. That means upon power up, we should not take more than 1 second to become operational mode. So how we are going to do? There is a 2 inputs. That means we need to measure, right? Measure the time. That is what it says between boot up till op mode. Okay. This is something like an assertive test case where we don't have a negative, or where what is it called? We are expecting something with some actions. Here action is nothing but between boot up how it's going to happen upon power up. That is an input. Input is power up and mode, and condition is power up. Entire process of or boot up. Boot up how it happens with a power up button. Power on. We can say the action is called as power on or boot up. So output is time difference between operational mode entry from power on time. So some instrument called oscilloscope. Okay, with oscilloscope we need 2 tapping points, or we don't need 2 tapping points, or depending on what sort of a processor we have, where it can give. Suppose power up has a pin number 20, where you can see the glitch of the signal pulsing at a certain level, 5 volts if it is. We can observe that with 1 pin captured there. And operational mode, if it is tied up with a LED, something say LED 2, it will have a port, something like a GPIO port or whatever it is. So these two we can see it, so that we can see the reference as 1 with the power up pin, other one as the LED port when it is going to become operational mode. So that difference we can find out with the help of this. So that will become a test case in terms of measuring. So input is power up mode. So we need to give a pulse to or pulse or reset to pin 20, booting the processor, measure using oscilloscope. What will happen is expected result is less than 1 second. That is what is the expected result, right? So that's how we are going to measure it with the power supply and try to validate the test case. Okay. Okay. Next type of requirements we have communication requirements. Let's see. Okay. Here you can see two requirements are there. The instrument shall communicate through CAN messages with outside interface. The instrument shall communicate its alive status at 1 second, at least 1 second. It means two things are there. We can combine these requirements to have multiple cases under one group, saying that proving this also can prove that it is communicating and it is also communicating its status at 1 second. So it is just a validation of this basically. So there is no verification, like there is no input that we can tweak or we can modify. So what sort of a test cases we can have? Test case 1 will have observe the output CAN message, check whether the CAN message are received at every 1 second. Next one, check whether the CAN message belongs to alive status. These are important steps to validate these requirements, right? Okay. Next, negative type, or when the instrument is powered, this is going to happen. So switch off UI. So what will happen is no messages are observed. No messages should be observed outside. So this is proving that the instrument will communicate only when it is powered up outside the box, and the rate at which the CAN messages are coming, how we can verify the rate is based on the timestamp, because every CAN message will have a timestamp in the logger outside in the host. With that logger we can see the difference between message 2 minus message 1. That should be 1 second. Of course it may not be exactly 1 second, it could be something like 980 milliseconds. It depends again to 100. Here tolerance of plus or minus 20 is there. You can see it can fall anything between 980 to 1020. So depends on type of system. Tolerance also will be there, so you may not get exact thing. So they will specify in the requirement accordingly, saying that for this tolerance it should work. So that way we need to verify the such requirements, any timing requirements or any unlock or any of the outputs that has a tolerance, we can verify that. So this is how communication requirements can be tested with the test cases this way. Okay. The last one being the watchdog requirements. So there are two requirements here. The instrument shall configure the internal watchdog to generate a reset to microcontroller with a threshold duration of 500 milliseconds. So what it means is it has a configuration saying that when it is up and operational, it should be configured for 500 milliseconds such that the watchdog will be satisfied with a pulse of less than 500 milliseconds. That is the next requirement. If it is not, the watchdog is going to reset it because it is configured for 500 milliseconds, right? Okay. So here cases we need to verify in the sense that first one is verify the configuration of the watchdog. This is theoretically or by seeing the code or by seeing the registers we can validate. Dynamically we can validate such a way that we can capture the pulse of the watchdog. Usually watchdog is a circuitry where it has a counter and that counter is configured for 500 and there is a decrement counter. The 500 becomes 499, 498, 427 like this. When it becomes 0, it is going to reset or pulse the reset pin of the processor such that the processor gets resets. So how are you going to emulate this? Somehow you make sure that you reconfigure the watchdog or you make it hang the program that is there in the this thing or capture the pulse. So what is responsible for pulsing the watchdog? So that should be less than 500 milliseconds. So that is what the second requirement talks about. At least once in every 500 milliseconds or less it should be there. So one is configuration, other one is whether it is pulsing properly or not. We are going to verify. This is how we can verify the watchdog sort of a requirement. Okay. So likewise we are going to have the test cases defined with test ID, inputs, conditions, expected results, and appendixes we have studied. Now having seen all this, let's try to understand the review checklist. We have done the testing of the high level requirements. Whatever I have demonstrated so far is writing the test cases from the requirements and how procedures can be written from this is what we have understood. Now having done this, we need to understand the checklist. Usually this will be a gating criteria for a particular test plan or test cases to make sure that the rules of the particular verification of the test cases are adhering to the requirement or as per the need. That is what we are going to do it. Okay. Okay. So this is an example template. Generally they use it. It is again specific to the organization or customer or specific process that is being followed in the type of embedded software. Let's try to go through this and try to fill up the checklist on what we have done so far. Okay. First one, our templates followed during the development of test case document. Yes, we had a document test template which we have followed, right? Yes. Are the valid equivalence classes analysis applied to all inputs of high level requirements? Yes, we had seen the equivalence classes in terms of the complete truth table and all that. And set of range in terms of inputs we have considered. Are limits values used for external signals to create specific cases? Here there is no external signal, but can is used. So there is a limit in terms of the signals like CRO, the values coming from there we have used. So it will become less. For inputs structured in a table, are bounds and one intermediate value of the table used to create test cases is what is the equivalence class. There is no structured input table, so this is not applicable. Is MCDC functional analysis used for the logic equations? Yes. Are particular test cases created for time related functions and state transitions? Yes, but we have done only for the time related. There is no transitions we have. Is one robustness test case created for each external inputs? Yes. We have the negative or the different values of inputs that we try to put it like robustness. So that is what is there. Is identification format of test cases? Yes, we have seen that every test case has its own unique ID. Is each high level requirement covered by at least one test case and one correct one? It's very important. Correct one is also very important. So this based on the review we need to fill this whether correctly it is done. Yes, we have done for each of the requirement at least one test case. Is each test case created covered by one scenario and by the correct one? Yes. The test cases like we have a test case for each requirement and that requirement has multiple scenarios and the correct scenarios we have identified. Are values of inputs and outputs defined for each test created? Is each scenario qualified as normal rate? This probably we are not done. This needs to be done based on the validation of test cases. This will be taken care of. Since we are not completely validating review and all that. Once we have that, we can define these things. That's what. In this justification, we should be able to report it, saying that they know what is my action for this, whether it is correctly done or not. Is the COTS test coverage analysis available? Is commercial on the cell phone? I think we don't have that. We say not applicable. So there is a two sections. One is guidelines, other one is rules. Rules are mandated to be followed as this. There is no solid justification to do that. It is also called as deviation and deviation approval, without which the report will not be accepted by the designated authority or approval from customer as well as senior. Guidelines is a description of the scenarios clear and accurate. Somewhat it is. So I will say no. We can add more description. Are the expected results defined for each scenario? Are the test bench specification defined for each test case? What we have done is we have done the grouping and identified the test bench or the setup that we require. Right? Yeah. The preconditions defined for each test case. Yes, we have seen that it exists. So this is how we are going to fill the test case checklist. It's called verification of test cases. It's objective and description and whether saying that is it followed up. So that is what we have to do for the develop test case from the requirements. So that is how checklist will be filled. Okay. Traceability. This we will continue in the next practical session in terms of upward traceability and traceability. So as I said, from test cases to requirements it is called as upward traceability. Downward traceability it is requirement to test cases. Okay.